All right. Appears to be live on the wrong computer, but it'll have to do. Yeah, it's probably going to be kind of pixelated or something. Inadequate. Maybe. Maybe. Maybe too bad. But we'll see how it goes. Um, Waiting for the viewer page to show up. And I have to pause it so I can see the chat thing. So it says, please stand by, which I don't really understand. Yes, I'm broadcasting, but we'll try again. There's always some sort of logistics. So link in the below if you're interested in talking some physics um, and such. I'm just going to do a response to kind of just nonsense raised by Hafla Day. Um, and he's just such an asshole sometimes, and how he brings up these his arguments in terms of paraphrasing it as if somebody has avoided or not referenced, his acknowledged his problem or answered his questions. It's just so irritating. Because when you do that, kind of ignores the results anyway. All right, it appears to be playing now, so I can pause this, hopefully, and yeah, go back to opening this, and I should be able to see the chat over there, because the chat in here doesn't work, quite obviously, mostly. All right, well, that seems good enough. I think the bases are covered. All right, so to answer Hafla Day, his problem is, all right, so you have these little bits that I'm saying are interacting in this kinetic way, and the implication is that kinetics doesn't allow there to be change. And I've sort of pointed out what's really changing, but I'll just draw the little X diagram again. Two things interacting, and you can view it two different ways. You can see this going straight through and this going straight through the interaction. Wow, this is really delayed. Or you can say the thing going this way ends up going that way, 90-degree turn. The thing going this way ends up a 90-degree turn going this way. Two ways of looking at it. Either way, the universe is exactly the same. So his the implication of his argument is there's no mechanism for change in the circumstance. And in a physical sense, that's true, but I have pointed out that these little bits that are banging into each other carry polarization and frequency. Now, frequency is kind of it's hidden in the sense that it's polarized frequency. So it's the frequency of something of the same polarization. So if I had a stream of things all moving in the same direction at the same, coming from the same place, hitting you, like the important fact is I'll just mark them with an X, is that some of them might be polarized and some not. And the ones that are polarized would be at a frequency. So you can just see there could be a stream of things, and the frequency is really just identifiable in the ones that are polarized, would be at the frequency. So there could be other bits in between the things that are being measured as having a frequency. It's just that those aren't going to be seen by the thing that's going to be impacted because of the frequency. And so it's the frequency of the polarization that really defines what a photon is. So when a photon's coming at you, a stream of light, there could be other gravitons, little quantons in between the bits of the frequency, like say in a radio wave. There could be lots of other little bits that hit you, but they're not polarized in exactly the same way as the first bit, and then the bit 3 miles later of the radio frequency. So it's only the polarized bits that are being counted by the electron that's absorbing or changing something because of this polarization. So, all right, so I don't know how deep I want to get into that. So, frequency is sort of a, it's completely dependent on understanding. For the frequency argument to make sense, you have to kind of accept the polarization argument. So that's really the key one. And the idea that things themselves have an orientation, and it's what's being filtered out of these interactions is orientation. So depending on the circumstances of polarization, that decides whether what is happening is this thing is taking a 90-degree turn, or whether this thing is essentially going through. What's really being counted is what happens to the polarization. Is the polarization transferred? And so the argument I would make is that polarization is transferred when quanton interact with electrons. Electrons filter polarization, so they collect it in a sense. So all the little bits that become part of the electron all have the same polarization. And that's what makes this thing function. And that's what makes the entire universe function, is that it's really just polarization that you're seeing as collections. It's collections of polarization, not so much collections of energy. It just makes the energy visible when it's polarized. It's a way of saying it. I don't know how else to say it. But it has an impact when it's polarized. It doesn't have an impact when it's not. Polarization is what makes everything work. Gravity, magnetism, electricity, all the forces are dependent on polarization. All right. So back to the school of fish analogy. And so the idea of this, the velocity argument, he used a wheel, I mean a circle as a description, not a wheel, but a round cup. And the differences in the velocities that are created in different positions on that circle spinning. And he's talking about how he's not deformed as he moves. Well, you're moving so much slower than the speed of light that your deformation is not visible, but it happens. Your atomic structure is substantially deformed through your movement. So a way of understanding that is to say, take the school of fish argument, and understand the school of fish has a balance. It's staying in one place. So now let's go a step further and say it's moving. And it's part of a collection of schools of fish that are moving. So then your school of fish isn't just a school of fish, it's a collection of a school of fish. Right? And you know where I'm going with this, right? Yeah. And then that collection is a collection in a bigger collection of collections of collections. And then that collection is a bigger collection of collections. And so I'll try to draw this so it's visible. So you have the movement of the fish in the littlest school, the smallest school, and you have the movement in the bigger school, and then you have the movement in the bigger school, and then you have the collections of schools. So this will be my attempt to draw it. Have to wait for it. Yeah, it's almost visible. So you can see the first little arrow here. So this is the first little school of fish, and it's rotating. And that means it's moving this way at this point, and then it moves down at this point, and then it moves this way at this point, it moves this way at this point, as from our perspective. But what's really happening is the fish are just changing. It's letting go of the fish going this way. It's taking in new fish going down this way. Then it takes in new fish going this way, and then it takes in new fish going this way. If you were to just cut this circle into a square, obviously it's happening on all the angles in between, but that's, no point in getting that complicated. And then this whole system is schools of fish are also moving. So these schools of fish are moving, and then these collections of schools of fish are moving, and then that collection is moving. And so you can just see how it goes bigger and bigger and bigger and bigger and bigger in terms of a dynamic. And the rule that holds that together is the idea of this pressure that exists that's polarized. Always some percentage of it polarized to the polarization of the original school. So that's a flat thing, like a galaxy spinning. It's a flat thing, and it will only absorb fish in one dimension. And then they have the right polarization. So that's one way of illustrating it. And the point would be is that all this stuff, that the real universe is made out of just those fish. It's just fish moving. The schools of fish are not real things. They're made out of fish, and the fish inside of them define their character. So if a school moves, it's because the fish inside of it moved. If you move, it's because the quanta that make you up move. Some of them change. They're exchanged out of their positions. Ones that were in a position, a location inside of you, that location was moving this way, and then it exchanged to go this way. That's how you move, is that there has to be an exchange of the bits that define your the substance of your locations. And so if you were just made out of pixels on a screen, the pixels change. So if you thought of movement as color, what's really happening is you could say red is up and blue is across and green is down and purple is right, and then you got to do the other two dimensions. And you could just see the colors move. You could see the colors change. That's the same. It's just that kind of effect. So let's see how much deeper you have to go. The idea of each particle moving the speed of light, I think, is the nature of the game. But it really doesn't matter if you just made it a checkerboard and just said that a thing goes from square, right to left coordinates, 8, V7, X is 7, Y 4, that location. And then that location changes color from a red square to a black square. And, that has implications to the rules of the game, because the rules say that, the red square has to always have black squares as diagonal or some kind of thing like that. And then the other squares tend to change because that square changed. So you can look at it that way. I'm saying that it probably works out the same mathematically if you did do that. If you did average it all out to being the same distance apart, it probably will all come out to the same answer mathematically. So it doesn't matter really how you envision it, whether you envision it as a field of changing color representing polarization or as little bits moving. The important part is to understand there's rules that create this idea of the pressure, the idea of the filtering out of an arrow. So the idea that I'm going to be there's balanced arrows coming at me from the environment from all directions, the same number of arrows. If something changes that balance, it'll change my composition. I'll end up looking like the change in that field. The field will change me. And in that change, I'll gain acceleration because now I'm going to absorb more arrows coming. I've made this argument, but if something shields me from arrows coming at me, I'll end up absorbing more arrows going this way than this way, which will cause me to accelerate forward. As I accelerate forward, that means I did absorb more arrows. That means I create a shadow on the thing that shadowed me. And now it is going to reciprocate by doing exactly the same thing, which is it's going to absorbing more forward arrows towards me, which means I'll get hit by less because it's absorbing them. It's changing fish that were blue for fish that were green, and the green fish behind me are going to push me forward, so to speak. I'm going to be changed because I'm going to absorb more of them. And so it becomes induction, and the two things induce the gravity. Just like electricity and magnetism, they're all induced in something. So when you take a piece of magnetizable, a piece of something that is a magnet will stick to, what's really happening is that you're inducing magnetism in that substance. And that induction of magnetism creates charge because the electrons now change their momentum. And when they change their direction, which way they're moving, they will expel their old movement, essentially. So whatever velocity they had in some other direction, they'll get rid of. And certainly if the velocity is higher or a new velocity, not just a direction change, but an actual gain in speed, then they'll expel perpendicular to that speed fish, because they have to get rid of some fish to gain new fish. So the rule is these schools can only have 1,000 fish, so you can't add fish to them. You can only take in new fish and get rid of old fish. And so when something's moving, it's getting rid of its old fish, the fish going the wrong way. And that's what that's what's expressed as what we call force. Those forces are real. They're real fish added to the field environment, and they hit things, proportional to the R squared rule, which is the light bulb rule. The further you are, the less of those fish will hit you. But they're going to go somewhere and hit something. It just means how many of them will hit you based on distance. How much of a shadow is cast, so to speak. So it's all ends up being a field structure. So when you think of these schools moving in schools, what's really happening is the individual fish positions are changing all the time, in the sense that the move from this square that was here has the option of continuing to have an arrow on the next square, the next square, the next square can all be arrows going this way, or there can be a change, which means that there's an exchange where this is released and the new direction is down. And that's the new fish kept. Yeah, that's pretty, I think that's understandable. So you have to understand that when something big like my hand is moving, yeah, I don't see it disintegrating and all the fish changing and all that stuff because I can't see the fish. Okay, this one fist, all right, the atoms in this one fist, right? An apple to the earth is the same as the atoms to this fist. So there's as many atoms in this hand, and we're not even to the smallest level. That's a whole 2 times smaller kind of equation to get to the real small stuff, the real fish. So you have to double this preposterous apple to the size of the earth disproportion, and you have to do that twice before you can get to the fish, where the fish are. So obviously you're not going to see your hand disintegrating because you're so on scale so preposterously bigger than the scale of the fish. Of course you can't see the fish. The fish are so fucking small. It's how can you possibly see the fish when you're living when you can see the earth? How could you see the apple? It would be an impossibility for you to be able to see the earth. Like through the earth right here, there's no way you can see an apple on it. It's clearly got apples on it, but you wouldn't be able to see them. So this expectation that you would sense somehow that your matter is in motion, that the fish are changing direction all the time. Yeah, you don't see it, but it's happening all the time. Every second, the snap of my fingers, billions or trillions, zillions of fish change direction in the snap of my finger. But that's overall is what's happening. When my hand moves, it means that based on the equation of the total mass of my hand versus the mass of one photon, that fraction, which is a huge preposterous fraction, right? It's one apple to the size of the earth. One apple to the size of the earth fraction means that each second of movement, yes, that's all it takes is one of those little apples gets changed over time, and you add up the amount of speed. So you go with the speed of light divided by that preposterous fraction, and then you'll get to the quantum level and know how many how many fish you actually need to change to go 1 foot. And it probably is a surprisingly few number, a small number, just because the speed of light is so preposterously fast and this movement is so slow by comparison. So this movement is almost, by comparison, as slow as an apple to the size of the earth. So those two, this motion speed compared to the speed of light is almost as preposterously disproportional as the proportion of the size of an apple to the size of the earth. So you end up with an equation where you could almost argue that it only takes 10 fish that actually change their direction for this to happen. Which could be surprising. I think it's got to be a higher number than that because I don't think the fractions work out perfectly, of course. So it's probably a billion fish or something, but it's a much smaller than you would think number, just because the speed of light is so fast and all the motions we do are so preposterously slow by comparison. Yeah, so I should work out those two fractions. I mean, I really should do the mass of the earth to the apple equation, which is basically the atom to the mass of something equation. The quanta to the atom kind of equation, and this speed versus the speed of light, and just measure those two fractions. and that'll tell you how many fish have to change for this to happen. Okay. Yeah. And I mean change permanently, durably changed. Like our actual position is actually changed, and instead of doing what it was doing, it's doing one thing, which is going in one direction. So again, it's to be explicitly true, you would argue that there is nothing really turns. It's just an exchange of fish. So if you want to go from doing this to doing this, you have to exchange the fish to do the arc of the turn. You have to do this exchange and then this exchange and this, all the exchanges to get to this. But the exchanges have to happen, and the exchanges, you're exchanging the right polarization of a thing going this way for something of the right polarization going this way, and you're just exchanging. You're doing that X thing in a way that counts, in that you've absorbed a new position. A position in a clock face has changed, so it doesn't say 12 anymore. It says 3. So let's just have it as a clock face, and just think of the numbers as being different directions. And when something moves, so to start off with, you have equal number of each direction, and then what changes when something gains acceleration is, the 12 position now is a 3. So now there's 2 3s. So you'll go in the 3 direction, kind of a thing. So it has to be thought of kind of as positions in a field, because that's all that really changes, is locations, the identity of what's at a location, the identity of the fish at the location of the clock face is what's really changing. The simple way to say it. But it's, I mean, that's the more accurate way to say it. But for practical understanding, you have to see it as being an interaction that caused a change of direction. The fish changed its direction rather than thinking of it exchanging direction. Mm-hmm. It's as if every pixel has to be used. So if I have a screen and it's all white, a white screen on a computer, let's say, and there's all these pixels, all these locations, what's really happening is let's say there's one black dot, and I'm just moving the black dot to different locations. Let me see how to explain that. Yeah, well, I mean, you can just see that it has to be, if it's occupying a location, that means it's not somewhere else. So I guess that's the easiest way to understand it. And if you understand all motion as being a balanced field, so for every arrow going up, there's an arrow going down. And so if I have 2 locations and I have used 2 down arrows, you can understand that the field, the rest of the screen, there's got to be an extra up arrow somewhere. Somewhere on the screen, there's an extra up arrow. So it's like that black dot. If I took the black dot away from here and I put it over there, you can understand that I need another white dot to fill that hole. So now the field is 1 white dot less. If there was the same number of white dots, it had to put a white dot there. So it had to move a white dot into that location. And by moving it, it moved it out of space, and that means another white dot had to fill that space. So you can sort of understand the conservation idea is that if I could actually pull things in real space, if I could take a quanta from here and put it over here, you'd almost understand that the effect would be a line of dominoes would tumble back and forth between those two locations of the impact of the extra domino I had to push out of its space when I put the black one here. When I put the black one here, I kick the white one out. The white one creates extra pressure that'll feed all the way back to the spot where I pulled the white one out and I left a hole, and that hole got filled. And so the two conservationally would have to vibrate, in a sense. There would be a domino cascade of cause and effect that you could trace between those two locations. One location feeding the pressure, one location creating the reverse, the opposite equal reaction. So I guess that's the good way to put it. So you always have to understand that when the fish is exchanged in the school, the field gains the extra fish. So the field becomes the opposite of what the school is. So if the school is going right, the field around it is going left. Okay, that's probably the way to say it. So, but there's no jumping. I mean, I can't pull a quanta in the real universe from here and then pop one over here. It actually does it the other way around, where the impacts are all pushes, essentially. And it just fills the voids of where it was pushed. There's the extra pressure created in front of, so to speak, the push, and it just goes forever. So if something stops moving, if it goes here and it's stuck here, well, the pressure is still making the pressure. Yeah, so it's constantly creating an imbalance in the total field. All right, I think that's an adequate way to say it. So I think I've answered his dilemma with there being some kind of causational problem. I mean, you just can't cut the mechanics too crude because it is so complex. So you can't just say, well, here's a wheel and it's spinning. Why are the fish going this way and going this way and going this way and going this way? Well, obviously inside the wheel what the fish are doing is a lot more complicated than that simple what the wheel is doing, because they're already caught up in their own material spirals. So they're changing directions zillions of times per millimeter the wheel moves. Yeah. And so the whole mechanism, the physical things, the quantas, don't, let's see how to put this. Let's see how to put it. You can never change the identity of them. The arrows are the arrows. The fish going this way is a fish going that way forever. It never turns into a fish going some other direction. It's always a fish going this way. It's just the ones that what you're trapping them for, what you're locating, is fish of a specific polarization are continually being exchanged, being let's see how to say it, being associated based on their polarization. So in a sense, there's a constant stream of things. I could draw this in arrows, let's say. All right, you might be able to get this. It's really hard to draw it, well, on the fly, especially. Um, so if I just drew a bunch of straight lines, arrows, and I just changed their, slight angle difference, you'll end up getting the idea that it's a spiral. I mean, it'll end up being a bunch of arrows, but in the end, if I just keep doing that, you'll have as many arrows going out as you have in, going through, going through. So it's almost like the idea of the circle is just made out of a bunch of straight lines at different angles, and what you have left over is the circle. But that's what's flying through everything that is technically associated with each other all the time. It's all the time new bits. It's just that the new bits are of the same polarization, the same orientation, and so they behave as if associated. Um, let's see. So we get back to the pressure argument, and how these things do get what creates the capacity of the electron to filter. So I guess it's the argument, out of an invisible kinetic response. And so what the fish can do is have its polarization change. So the other thing to understand is the fish has a polarization. And so its direction can never be changed. Its speed and where it's going doesn't change. But what changes is how it's oriented. So by going into an electron sideways, let's say the electron spinning this way or something, the fish gives its polarization away and changes it to flat. So yes, the field gets something with flat polarization, and the electron kept the well, I don't know which way I used it, but this is the idea. The quanton is shaped like a frisbee, and those are all the choices of polarization are those 360 degrees. And what happens when it goes into an electron is that you don't change the fish going through the electron. All the quanta that make up an electron, let's say, are always new ones all the time. Every zillionth of a second, it's a new fish in the school. It's just that the fish has changed its polarization. So the fish going out of the school leaves with this polarization, and the fish that went in, it keeps some fish inside keeps this polarization. And so that's what's really happening is it's just exchanging polarizations. So something coming in at one place at this wrong polarization is able to be kept by the electron. Say this one's coming in at the wrong polarization, it's able to be kept by the electron because it gets hit the right way, and it exchanges polarization with something going this way. So this polarization changes, and this one changes to the polarization needed to stay in the electron. Oh man, so that's the subtlety of the mechanism. The only thing really moving, the only thing really changing, all the bits are moving and you can't change their movement. The only thing you're changing is their polarization. So it's kind of like the idea where I said it before, and Hofstadter has even used this as an example in some of his examples. If you have little colored squares on a axle, you could spin those colors in such a way where you would create the illusion of something moving. Now, the little squares aren't moving, but because you change the colors the right sequence, you can create the illusion of a thing moving. And that's sort of what's happening. The reality we're seeing, the material reality, everything we're seeing, all this stuff happening, is just a change in the color, the polarization. It's not a change in the physical bits. So even a nuclear bomb, as I've said before, it's like there's a nuclear bomb around us all the time. It's just that it's of chaotic polarization, so it's invisible, and only becomes visible when it's all the same polarization. Then it's a problem, because then it disrupts, then it has force impact. If a bunch of fish come at me and they all have the same polarization, it's a lot different problem than if they have random polarizations in terms of what it's going to do to my physical body. My physical atoms can absorb quanta hitting it all the time, lots of radiation hitting it. But if all the radiation has the same polarization, then it can't exchange polarizations anymore. It can't maintain the structure of the electrons because all the polarization is the same, and all the electrons fall apart because it can't do the polarization exchanges. So what we see as energy is just filtered polarization. It's not really new quanta. It's not really quanta, extra quanta coming at us, extra bits moving towards us. It's just that they've been identified by polarization. So it's like the light we see was quanta anyway. It was gravity, if you want to call it that. When you see beams of light, that was really just gravity, and now it's been labeled with polarization. So by labeling it with polarization, it now has an impact on my electrons. It now will affect them. Where when it was random polarization, it wouldn't change anything in my electrons. So I wouldn't be able to recognize it. So the forces are all out there. Everything that's moving, every little bit of radiation is all radiation that would exist no matter what happens in the universe. It's just that its polarization is what makes it visible. So when a radioactive isotope is irradiating, it's irradiating radiation of the same polarization. Each beam, each ray is of a consistent polarization. And that's what makes it identifiable. That's what makes it disruptive to electrons. And it's really disrupting electrons that makes energy recognizable, because it has a cause and effect, cascading effect. It disrupts the momentum of the electron, which disrupts the other electrons it's associated with, the other schools of fish. The field gets disrupted around all those things when you change one element of the field. Yeah, that's probably a good way to say it. So the entire universe, to be explicit and fair, what we see in the universe is just polarization. The same amount of quanta exists there. So the moon is not really, there's just as much moon outside the moon as there inside the moon. It's all the same. It's the same amount of stuff in the empty space as there is in the space we call matter. It's just that the matter is of a consistent polarization. It's of filtered out polarizations. And those filtered polarizations are what we're seeing. It's what we're bouncing photons off of, is the polarization. Yeah, that's got it. So I don't want to beat it to death, but I think this was understandable. Just to understand, that with the whole, what it looks, what it looks like. You just have to go that one level deeper to understand that what's really changing, the only thing that gets changed in all of the stuff happening, is that some of the stuff that was moving this in a direction. So these are the rules. All the bits are moving. They're all moving the speed of light. They can never change their direction. They just can't. So they go forever in that direction and fly out of the universe eventually. And so all they're doing while they're in this pressure field of the universe, the part that we're in, the bubble of stuff bouncing around, bouncing. Yeah, not really. Let's see. Yeah, the bouncing part is one part where I guess I might have to modify that rule. Well, I'll think about it. But I mean, the key thing, let's just say you can change the direction of a quanta in some circumstances. You really can't. Doesn't logically make any sense. So eventually the universe is just going to run out of arrows, theoretically. You know, there just won't be any more crossover. All right, but I'll have to draw a picture of that. So that'll be the next issue to is the density of the arrows. How many arrows can you have going the same way for how long? Because that's sort of like what we have here as a history. So we have, say, 13 billion years of the universe. Somehow, you know, in 13 billion years, we still have arrows going that way. Yeah, there's still some of them coming from somewhere. So the definition of that somewhere would be interesting. But that might make the universe infinite. And it's just in this location where the polarization is getting broken that you have what's called a universe. So it might dispense with the idea of a Big Bang theory, actually. So I just see these videos are really, they're so productive in a way. Just talking through this stuff, you come up with new stuff, and why should I assume the Big Bang is at all necessary? So yes, this almost makes the argument that what's outside of our universe is just randomized polarization. Nothing is polarized, specifically. So it's all random polarizations coming at our part of the universe. So it's all invisible. It's just gravity, and that could go forever. All right, so that's an interesting, and so it just negates the necessity of a Big Bang as an initiator of a universe. See, where would the Big Bang would be of no use in a sense if all we're talking about is changing polarization. You wouldn't need a Big Bang to cause the change in polarization. So yeah, I've negated the necessity of creating an initial force because the force already exists. And the only thing that's being created in this universe is that once you start fucking up the polarization, once I create a wheel, once I create an unbalanced wheel, let's say, all right, a crooked wheel, then I create imbalance in the field and make it possible for more crooked wheels to be created. It's if I created a perfect wheel, then there's no consequence. It's when I create the imperfect one that there might be more of a consequence. But I'll have to think that one through too. So as soon as you give something velocity, as soon as I move a physical object, a material object, I'm creating an imbalanced wheel and putting extra polarization into the universe. And that extra polarization will easily manifest into the creation of another wheel, another imbalanced wheel with a different momentum. Oh, that's good too. So there's two good elements here. Okay, so the infinite field, field of gravity, gravitons, quantons, arrows, and the idea that broken wheels, broken conservation, creates more broken conservation. It induces. So Yeah. 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 So anyway, so yeah, that sounds really valuable. That this is a good point. Um, yeah, very good. So yes, so I'm correct. So okay, so the point is that the universe is made out of these kinetic bits, little tons, elementals or fundamentals. So it's made out of little fundamentals, elementals. Let's call them elementons. Okay, there. I got a word now. The universe is made out of elementons. They move the speed of light, and they have an orientation of polarization. They have a shape. Um, they're a frisbee flying on end at a specific angle, going the speed of light. They'll never change their forward direction. They only move in one dimension, and they always go that way, and they never do anything else. They'll never change their direction, but what they can change is their polarization. And by having their polarization changed, you can create frequency of same polarization. So you create what we call light. So those are elementons coming at you with a consistent polarization at a specific frequency. So at a specific point in time, there's an elementon with exactly the same polarization. And and in the case of magnetism, it's just strictly polarization. And the fact that the electrons, if they're positioned in certain positions in certain materials, they'll be affected by that polarization, induce magnetism, induce a current, and in turn, the electrons will move. The velocity they gain will be expressed as a electromagnetic force that they will reciprocate back at the force that affected them, and they will induce a effect of the magnets attracting or repelling. Yeah, so it's all in there. We have shit by Ken. Well, Ken's kind of nutty. Create sound. Well, hopefully this video has sound. It looks like the little sound thing's moving. The fictionality stinks. Well, fuck you in the ass until dead, you stupid cunt. The two cannonballs. How does one do the fishy stuff? I don't even know what you're talking about cannonballs for. All dancing in tune. Fuck you. Quanta can't change. The photon can. The photon can't. Because it's just the distance between them, not them. Yes, that's right. Turtles on turtles for every theory. Fuck you. Create sound. Fuck you. The squeaky wheel. Fuck you. Fuck you. Just fuck off, Ken. Fuck you. I mean, really, you're just going to be an asshole. Really, just fuck off. The fuck off button. Should give me some kind of fuck off. Used to be a fuck off button here. Yeah, I used to be able to tell people to fuck off. Yeah, let me try this thing over here. This crappy computer probably can't handle me clicking on this shit. Ooh, quite obviously it can't. I just disappeared entirely. I don't want to go to your stupid cunt page. I don't know why it sent me to your stupid cunt page. Yeah, fuck you. Ugh, I'm just so sick of non-responsive comments. There, you're blocked. Happy? Asshole. I mean, you gotta make an argument. You can't just type one sentence crap. It's a fucking video. Why don't you learn how to make a video, retard? So I can mock you properly. fucking cunt. Funny how it doesn't let me go back here. Alright, so that chat was worthless. Yes. Adobe Flash, blah, blah, blah. Yeah, this computer is just so slow. Really shouldn't be this bad. I mean, it's a, it's a 500 megabyte graphics card. It should be able to do something. Piece of shit. Obviously, piece of shit. Do. It's still trying to load the page. Blah, 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 blah. So anyway, so I think I've pretty much accomplished my task, which was just to do a response to Holiday, which I think I did. So unless we get a decent chatter or somebody joins the room, I think I'll leave shortly and such. But good work done. Yeah, I really like this. The Big Bang really has nothing to do with energy in the universe. I mean, as funny as that sounds, Big Bang is just polarization, if anything. It's a polarization explosion, not an energy explosion. It's not actually creating the bits. It didn't make the quanta. Yeah, well, boring, you're done, so fuck you, Ken. Haha. Nothing I hate worse than assholes who show up in a room to say, I'm bored. Fuck you, then. Fuck off. I mean, how many times can you be asked to leave, you jackass? I don't fucking knock on your door, cut face. I don't want to smell your dumb fucking anus. So what are you doing sniffing mine for, you stupid shit? Just fuck off and die. God, such a fucking piece of crap. Rude little obnoxious troll. You don't know shit, and you can't say shit, you can't articulate shit, you can't do shit. You're fucking retarded. You do the fucking universe a favor by giving your polarization back. No, you can keep saying you typed what. I don't care. You're typing shit. That's all I see. I see shit. That's all I see is shit being typed by you, you shithead. You're 99 times out of 100 incomprehensible and off subject. And all I see is shit here. How do I make anything out of this crap? Create sound. What was I talking about sound? What was I talking about turtles, you dumb fuck? It's not turtles all the way down. I'm saying it's fucking arrows all the way goddamn down. Arrows are a lot different than fucking turtles, fuckhead. And it's obviously not all the way down. There's the fish. The fish are different than the school of fish. Obviously, it's not the same thing all the way down, is it? The fish are a lot different than the school of fish. Just as a human being is different than the cell. The cell is not a human being. Well, the fish is not matter. Oof. So I guess I have to find some moderating tool or whatever. I wish they'd make that obvious. Apparently blocked people can still comment. Add or remove moderators. Well, I mean, I should be a moderator. I have appropriately said, fuck this cunt. I don't know why it's not fucking the cunt. Here we go. Report block user. That's it. Well, we'll put them on timeout. Yeah, fuck you. Fuck you until dead. $300 it'd be so much better if they gave you like 300 minutes. You need to time out for the night. Anyway, it is nice that they delete the messages apparently, so that's good. So when he's been time out, his messages are deleted. Excellent. All right, enough of that asshole. I mean, some people are just obnoxiously rude. I mean, I don't find your theory, your counter theory of whatever it is, babbly boo, to be at all interesting. You're totally not productive to my thought process at all, as clearly reading your comments just was obnoxious and distracting. You're useless to this process. To my process. Half of the day is more constructive a troll than you are. And that's sort of an amazing statement. I have gained more in responding to Hafladay's imbecilic nonsense than I have gained from responding to anything you've ever typed. Fucking cunt. Anyway. You're not a muse. You don't inspire greatness, you inspire diarrhea. So, anyway, yeah, I'll keep doing these. You know, I think this is a good way to do my response videos. Anyway, it gives there an opportunity for some sort of interactive participation. So at least I'm providing the opportunity. In your theory, is gravity a push or is it a polarization? It's always a polarization. So that's the key to it, though. It's a little bit tricky, right? Because all the electrons are polarized differently in your matter, right? So there's always an electron polarized to the gravity coming in the random polarization. So they all match, though. The point is there's just as many crooked electrons in you as there are crooked polarizations coming in from gravity. But the actual force effect of gravity is because of the polarization. It wouldn't have any effect if it wasn't because each individual piece of gravity has polarization. It's just that it's the two randomnesses in the case of gravity kind of match. And it's when you become a magnet that you mismatch the connection. So now there's a whole range of gravity you're invisible to and a whole range of gravity you're twice as affected by. So then the polarization becomes important when you're a magnetic material because now you're polarizing the gravity. You're filtering for specific polarized gravity. So magnetism is just gravity magnified. It's funny, the word magnetism, magnify. It's just gravity magnified by using discrete by taking advantage of discrete sensitivities to discrete polarizations. So by polarizing your electrons in one orientation, which happens in a magnetic material, no doubt, you become twice as affected by certain polarizations and invisible to others. So essentially a magnet is it's like a polarizing filter. It's like the little bars. And only the frisbees coming right at it go through the bars, and all the frisbees going the wrong way hit the bars. But in the end effect is a force of push. Well, again, it pushes. it's sort of ignore for the sake of a mental image, yes, but you have to understand what push means. Push means absorption. So you're absorbing the gravity. Now it's not exactly a push then, right? If 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 I'm gaining extra fish from the gravity, in a sense, I'm exchanging fish. Fish come in one way, I release fish going the wrong way, I accelerate down. That effect isn't exactly a push, because I'm absorbing it. But I'm just saying push is kind of like we just used the word to describe the idea of the extra force. So I'm just saying, obviously, in that sense, it's a push because the extra force is obvious. There's more, there's more fish of the right polarization coming down on me than is coming up from the bottom at me. So from a specific point of view, there's obviously more polarization coming down than it's going up in one orientation. So in this orientation, I have more, because it's been filtered, a shadow has been created. The shadow has been created out of filtered gravity. So I'm getting less gravity of a specific polarization. And because my matter can only absorb so much anyway, of all the same, I'm being, it's as if it goes through me because I can't use the extra. I can't be affected by the extra. So the gravity coming down of the right polarization affects me. So in that sense, it's a push, because there's more polarization coming from one direction than the other. Same amount of gravitons. It's just that their polarization is different above me and below me. The ones coming up are different polarization than the ones coming down. Yeah, that's a simple way to say it. So if that's push, then yes, it's push. So attraction isn't really attraction. Attraction is field repulsion. You're There's no other way to look at it, right? There's no such thing as real attraction. There's just a kind of repulsion. And it sort of makes sense in almost everything. You think about even our relationships with other people. We're repulsed by loneliness, kind of a thing. So you could say that they were attracted to somebody because we're repulsed by not having them. But yeah, it's all, you gotta have the negative before you have the positive kind of thing. It's all the, you gotta have the deficit before you can have the profit. It's all that kind of thing. The negative first. The absence, the broken. The error, and then the correction. But yeah, you could use a million different analogies to just see that it's, when you really look at the force laws of the universe, they're all negative forces. Repulsive. So, thank you. See, Ken, that's a proper kind of question thing. Asking questions, that's a good idea. And there would be some kind of question other than, how big exactly is your asshole? That's not a good question. Not likely to get anything but a repulsive reaction out of me. You know, hang in there a little. See if we get to 10 viewers. I don't think we've gotten over 10 before. We're at 9. See if we can pick up one more viewer. Come on, one more, just for fun. Come on. Yeah, and just for random fun. For the sake of random fun. Come on. One more. Come on. That ain't gonna happen. One of the 9 will get bored. He's just waiting for random shit. Fuck that. I ain't gonna watch this asshole. Hey, asshole, random shit's random shit. I don't give a shit about random shit. Ah, we made the 10. There we go. So now what do I do? Celebrate of some kind? Is there a way to block gravity? Well, so you're not getting it. No, there's no way to block the actual quantons. So is there a way to change gravity in the sense that, is there a way to change the polarization? Yeah, but it requires force. That's the catch, right? So whatever force you want to get from the gravity, you have to apply just as much force to change the polarization. You know what I mean? So you have to put in filtered polarization to get filtered polarization out. So if you want to change gravity, you would have to actually change the polarization of the gravity, and that would require just as much force, theoretically, as whatever you're gaining from it in terms of losing some kind of effect of gravity. So it's just economically not viable. It's always going to take some kind of, let's create a superconductor, or let's create some kind of other mechanism that allow you to negate um, gravity through magnetism or some other polarized version of gravity. I mean, magnetism is just a polarized version of gravity, so in a sense, it is blocking gravity. Um, but see how expensive it is. Because you have to put the energy, you have to put the filtered polarization in the form of electricity, which is filtered polarization. I mean, when the electrons move, they create fields that go out. Those fields are what you're using to change the polarization. See, so just conservation laws are going to mean that whatever gain you get from your anti-gravity is going to be very expensive, in the sense that you're going to have to create a lot of polarization to undo the polarization of gravity. It won't be energy cheap, let's just put it that way. Is there plenty of energy in the universe? Plenty of polarization? Yeah, every atom has a ton of polarization in it, which is realized by the nuclear explosion. So obviously, if you create a more efficient um, nuclear, um, what do you want to call it, conversion, converting atomic energy, polarization, releasing it in some sort of more efficient manner, hugely more efficient than the silly nuclear power plant, then you could control gravity. But you have to understand that you're manipulating huge volumes of polarization, which are always going to be kind of dangerous. I mean, your electric conductors will be, hugely energetic, in terms of the amount of polarization you're filtering and controlling. And so it's always going to be a little bit dangerous, because if any of that releases, it'll just disintegrate your matter. I mean, the polarization is, in a sense, a kind of poison. That's why we're affected by it. It's poisonous to our structure. The electrons don't like it. And so when you hit it, you hit the electrons, it's really disruptive to their position and condition, and it'll break the atoms and break the electrons. It breaks everything. So the radiation problem, I guess is all I'm saying, is theoretically possible, but it's going to require a really high level of technology to be able to control the volume of polarization that will get you the effect you're after. Yeah. So yeah, you're going to need a power source. to do. Yes, you could do anti-gravity, but you're going to need a power source. And in the end, it's going to end up being the same thing as a rocket, right? So it's going to be just as much energy as just shooting yourself through the gravity, pushing yourself against it, having their force applied. So in a sense, negating gravity is going to be probably visually not that big a difference between shooting a rocket off, because somewhere to go up, you have to do the down force thing. You know what I mean? To shoot a laser, you have to let polarization go the opposite direction. Somewhere you had to release radiation in the opposite direction. So you can't create directionality, uh, polarized directionality, without releasing it in the opposite direction somewhere. Somewhere in the opposite direction, the stuff has to be released into the field. So if you got more fish going this way, somewhere in the field there's more fish going the opposite direction. Yeah. And I'm frozen now. Happens always about an hour into these things, it freezes. So even on the other computer it did that. Fuck you, Google. Yeah, that's about all I can say. I'll have to watch one of these and see how abrupt these endings are. I just moved a little bit. I moved a little bit more. All right, I might be back. Maybe. Yeah, a huge delay. So I don't know what. Yeah, it's starting to get fucktarded. Well, just froze again. So I think the rational thing to do is surrender to the freeze and say, yeah, I'm out of here, kind of thing. Let me close the chat, see if that helps. Come on. Hello. Google. Yeah, anyway, I'll have to see if this freeze means I am no longer making video. I'd say, could it be possible that gravity is an illusion like time? Well, again, illusion is the wrong word. No, there's no way it's an illusion. So time isn't an illusion anyway. Time happens. Time is what it takes for things to move. So it'd be stupid to say time is an illusion. I mean, it's a function. It's a byproduct of the function. Let's put it that way. It's a byproduct of the function. So strictly speaking, I don't think you'd call it an illusion. Well, good. It's not frozen. It's good to know. I can't tell. I just don't. See, right now it's completely frozen, and even my little speaker bar isn't moving. But at least before, my speaker was still moving, but it's not moving now.
Can you hear me?
So it's really hard for me to tell whether I'm out of the game or in the game. But we'll see. So I don't know if it's still working. Can you hear me now? Can you still hear me now?
Can you hear me?
Can you hear me now? Type something like you can hear me now. Apparently the chat still works, but my damn, window is frozen or something. Anyway. Maybe there's a delay in when the chat even shows up. I don't know. So, could it be possible gravity is an illusion like time? Okay. Yeah, time's just not an illusion. Byproduct of the function. That's the best way to put it. Time is a byproduct of the function of the universe. The universe is farting it. Now we have a catastrophe, I think. The chat disappeared. That must be consequential. Somebody said hi. Fuck you, don't do that. Whoever you are. Just screwing things up. Hi. Fuck you. Browser's not working right. It doesn't need any extra crap. Yeah, so now it's frozen. Good. So now it's rock solidly frozen. Frozen solid.